Hi, ladies and gentlemen. This is another in my lessons on uh, statistical stuff that we are working on right at the moment. We're looking at Unit 4. And in Unit 4, the next topic in that unit is called permutations. Okay? What is a permutation? Well, it's a way of saying how you arrange things, but it's selecting things where order matters. Okay? Well, hmm. It's kind of difficult to explain this, but assume that if you had a 10 people that were running for offices in your club, and you had a president, a vice president, and a secretary, you had three positions. Well, 10 people could fill those three positions. How many different ways is what they're asking. They're asking you a permutation. How many people would fill these three positions? And the way you do that is you put the total number that you've got on the outside. So in this example, my permutation would be 10 people, and you're taking them three at a time. And there's three, it's an order of three things that you would be looking at. So let's do a couple of these. If I wanted to do P 5, 5, the way you do that is that you actually have a formula for permutation. And that formula is to take the n factorial divided by n minus r factorial. So in this situation right here, we would have 5 factorial divided by 5 minus 5 factorial, which is equal to 5 factorial divided by 1. Remember, 0 factorial is actually a 1. And then you can, I showed you how you could figure out the factorials, and doing all that multiplication seems so long and hard, especially when you got calculators available to you, right? So let's see here. How could we do this on a calculator? Well, one of the things you can do is you can say, well, I want to find 5 factorial. You press 5, you press math, you go over to this PBR here, and then number 4 is a factorial. And you hit enter, and it tells you that's 120. Okay? Let's do this next one down here. So we got 5 factorial divided by 5 minus 3 factorial. Well, that's 5 factorial divided by 5 times 2 times 1. Well, that's just going to be 2 on the bottom, isn't it? So that's 100. 5 factorial was 120, and dividing it by 2, that's going to be a 60. Really easy to do these things. Not a problem. Okay? And I'm showing you here how these are done. Let's do this first one here without any difficulty at all. 6 factorial divided by 4 factorial, 6 factorial divided by 4 factorial. Well, that's really going to be 6 times 5 times 4 factorial divided by 4 factorial. And those are going to cancel out, so I'm going to get 30. And this one is going to be 10 factorial divided by 8 factorial. That's really going to be 10 times 9, which is going to be 90. And this one is going to be 4 factorial divided by 1, which is going to be 4 times 3 is 12 times 2 is 24. Just like that. Okay? So, this question is typical of the word problems that you would get. It says, how many ways can Linda hang 6 paintings in a row? Well, in that situation, you've got 6 paintings, and you're going to find the permutations of 6 paintings 6 at a time. So that's going to be equal to 6 factorial. Well, once again, I don't want to do that one in my head. I'm not that fast any longer. So I'm going to push 6, math, PRB, number 4 for factorial, hit enter, and it's going to tell me it's 720 different ways. So this one says, how many ways can Linda hang 4 of the 6 paintings in a row? Well, that's still going to be a 6 permutation, but we only want to find 4 of them. So that's going to be equal to 6 factorial divided by 6 minus 4, which is 2 factorial. So that's going to be equal to 360. I'm doing those fast and in my head, but I think you guys can see that 6 factorial divided 6 factorial 720, 2 factorial is just a 2. And so when I divide 720 by 2, I'm going to get 360. Okay? So what if we have objects that have we have sets that have like objects? The example that we give you is that we can still use permutations, but if we wanted to find out the number of ways that we could write the letters that are in parallel, that's the word we're going to use, and we're going to write those out. Well, how many letters are there in parallel? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters in parallel, so 8 permutations. And how many ways are we going to write them? 8 different ways. But we're going to divide that by any common letters that are in here. Well, there's 2 A's, right? So that's going to be a 2 factorial. And there are 3 L's, so that'll be a 3 factorial. My periods aren't showing up there that closely. And when you do that, what you're going to get is this P of 8 over 8 is some big number, but you're canceling out a lot of different things as you're going. And what you wind up with is 3,360 permutations. There's 3,360 ways to arrange those 8 letters, okay, where order matters. Okay? So, how many different ways can 4 people finish a marathon? Well, think about that. How many different ways could you do that? Well, that's going to be 4 people, permutation, 4 different ways, right? And so what you're going to wind up with is 4 factorial divided by 1, which is equal to 12 times 2 is 24. So there's 24 different ways those 4 people could be put together in a finishing order. Hopefully you got the idea of how these permutations work. What we're going to take up next are combinations, which is a slightly different topic, but they go together very closely. Okay? So I look forward to seeing you next time.